problem learning this, right?
Yeah, learn it.
Please learn it. Okay, so you should also remember that what is happening, the SRP is increasing like this. Okay, SRP is increasing like this. This is also very important. If you don't remember that SRP is increasing, decreasing, में आपको अगर भूल जाए, if you forget this, then what you will remember that chapa is positive. If chapa is positive, that means all of these will be what? Negative, 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 and the lithium will be most negative, right? Lithium will be most negative. Is that clear? Yes or no? Please tell me, all of you.
Yes, sir.
Okay, fine. So now we will write the applications of electrochemical series. Okay, applications of electrochemical series. You guys remember today is a test, okay? So we'll have class and after that we will have test. Right. Applications of electrochemical series. See, the first application is the same application that we did yesterday. We said that first application is what? It is used to determine the determine oxidizing power. Give a second. And reducing power. Okay, oxidizing power and reducing power. So what do we know about this? If SRP if the SRP is low, what does that mean? It means reducing power to reduce something is high, and oxidizing.
Sir, we did this.
हाँ फिर से लिख लीजिए ना इसमें एप्लीकेशंस में। ये बोले कल हमने पढ़ा था ना, yesterday we did same thing. Just write it again. Used to determine the oxidizing power and reducing power. Now write a question on this. Write the question and then I will explain what the questioner is asking. Okay. Let me know when you are done writing the question.
So I'm done.
Done? Okay. Arrange the following metals in the order in which they displace each other from the solution of their salts. So the question is saying, what will happen? I have these things, okay? I have a solution in which we have the ion of aluminium. So the ion of aluminium will be what? Al3 plus, because it is the most stable one. Copper will be what? Cu2 plus. Mg will be what? Sorry, Fe will be Fe2 plus. And here we'll be having Mg2 plus. And here we'll be having zinc 2 plus. Okay, got it? Yes or no? So this is, they are saying, arrange the following metals in the order in which they displace each other from the solutions of their salt. So you'll imagine it like this, that all of these particular metals, they have a solution of their salt, and in the solution of their salt they will be existing as ions. Is this clear? Yes or no? Please tell me, all of you.
Yes, sir.
Yeah, okay,
Yes, sir.
fine. Now we all know what will happen if I add zinc in the solution where I have copper 2 plus. You know what reaction will happen? Zinc plus copper 2 plus will give you what? Zinc 2 plus and copper.
Plus copper.
Correct? Yes or no? Fatima, Sarah, understood?
Yes, sir.
You know this reaction. Okay. So what is zinc doing? Zinc is displacing copper. Yes or no? What is zinc doing? Zinc is taking the place of copper. Zinc is taking the place of copper, and it is converting itself into iron. That means what will happen? Zinc will displace copper. Zinc is doing what? Zinc is going to displace copper. But if we do the same thing, what should we do? We should do, let us say, if we add copper into zinc 2 plus, then what will happen? Then nothing will happen. Okay, so because you can see now, this is what this reaction. Forward reaction is like this. Zinc is only able to displace copper. Copper will not be able to displace zinc. Is that clear? Yes or no? Please tell me.
Yes, sir.
Okay. So now what you will use? You will use the what they are asked. Okay. So one thing. What is happening with zinc? Tell me. Zinc is getting oxidized. And what is happening to copper?
Reduction.
Reduction. And who is reducing copper?
Zinc.
Zinc is. So what we are asking about? We are asking indirectly the reducing power. Right? So you have to arrange them in arrange the following metals in the order in which they displace each other. Okay, so you have to arrange them in the reducing power, in a way that you can write in the decreasing order of reducing power. Okay, in the decreasing order of reducing power. So if the reducing power is high, then SRP will be what? High or low? Tell me. If the reducing power is high, SRP will be
Lower.
low. Okay. So now in the electrochemical series, you tell me which of the following elements, which of the following metal it comes first. सबसे पहले क्या आता है इसमें? Which comes first? See, I am telling. Okay. So what is the trick? How do we remember this? We remember it like this. So in the examination, what you will do? In the examination, you will be saying the mnemonic. You will say le ke barat. Is there anything? Le ke barat. Is anyone of le ke barat here? No, na?
No,
No.
sir.
लेके बारात काना मजे से आया. लेके बारात काना मजे से आया. So is there anyone here? Is मजे से है ना? So मजे is coming first. That means it is what? It is having the lowest. It is having the lowest SRP. So मजे will be first. Okay. So we have done लेके बारात काना मजे से आया. What is the next thing? What is the next thing? नहीं नहीं.
Aya.
No. I did not hear what Fatima said, by the way. Fatima, what was second line?
कोई निगाह
नहीं. That is third line.
Oh, second line. मंजन का.
हाँ, मंजन कर फेंक दे. So is there anyone coming in मंजन कर फेंक दे? Is there any element from मंजन कर फेंक दे?
Zn.
Zn is there. Okay, so after Mg, what will come?
Zn.
Zn will come. मंजन कर फेंक दे. Anything in कर फेंक दे, मंजन कर फेंक दे.
Sir, but before Zn, Al will come, right, sir?
हाँ, मजे से आया. Yeah, correct. आया is also there, right? मजे से आया. Al. Correct. मजे से आयन. After that, मंजन कर फेंक दे. So in मंजन कर फेंक दे, what do we have? We have zinc, and we have फेंक दे में Fe, and then फेंक दे is Cd. फेंक दे is Cd. So after magnesium, aluminium will come, and then zinc will come. मंजन कर, then Fe will come. फेंक दे. Right, and then what remains? Aluminium is done, Fe is done, Mg is done. So remaining is copper. So we'll just write copper. So this is the order. That means Mg can displace each of the following. If you will add Mg in any of these, if you will add Mg in Al, copper, Fe, or Zn, then what is Mg going to do? Mg is going to replace all of them. Okay. Now, what is Al going to do? Al is going to replace each of the ions in Zn, Fe, and copper, but not for Mg. Al cannot replace the ion of Mg. Zn can replace the ion of Fe and copper, but it cannot displace the ion of aluminium and magnesium. Fe can only displace the ion of copper, and not for zinc, aluminium, or magnesium, and copper can not displace anything because copper is having what? Positive standard reduction potential. So copper is very happy getting reduced. It does not have any reducing power. It cannot reduce anything else. If there is any chance of reduction, it will itself get reduced. Okay, so it has a very low reducing power. It will not reduce anything. Clear? Yes or no? Please tell me, all of you. Yes or no? Right? Okay. Fine. So this is first application of the electrochemical series. Next is determination of anode and cathode. Determination of anode and cathode. So what happens in anode? Tell me. Oxidation happens in anode. Very good. If oxidation is happening in anode, then that means its SRP will be what? SRP will be low. It is not going to reduce. Hai na? SRP will be low. Correct? Yes or no? Please tell me. If oxidation is happening, then its potential to get reduced is what? It is very low. Yes or no? As you look here, zinc was there. So if SRP is very low, that means it will be having what? It will be higher in series. Okay, higher in series, that means manjan kar fek de. So we are talking from top to bottom. So top to bottom, manjan kar fek de, right? And before that, what do we have? Leke barat kana maze se aaya. After that, we have manjan kar fek de. After that, we have koi nahi kahe sundari pyar bari. So the topmost is what? It is having the lowest standard reduction potential, and that is why it will be the anode always. And then after that, if you have those two couples, let me show that. If I talk about, if I want to make a cell of lithium and potassium, so which is higher? ऊपर कौन है? Higher का मतलब ज्यादा value नहीं, higher का मतलब which is above. So lithium will be above potassium. Yes or no? Please tell me if I write it top to bottom. Yes or no, guys?
Yes.
Right. So here lithium will be what? Anode, and potassium will be cathode. If I want to make from potassium and barium, then potassium will be anode, barium will be cathode. Okay. And you can also see zinc is here and copper is here. So copper is always what? Anode, and zinc is always anode and copper is always cathode, because zinc is higher than copper. Zinc is in the top. Zinc pehle aata hai. It comes earlier, higher in the series. And for cathode, we have reduction. And for reduction, the standard reduction potential should be high, and it will be what should I write? It will be higher, top, upper, up and down likhte hai na. It should be right. It should be up in the series. It will be up in the series. It will be down in the series. Higher and lower में confusion है values का भी. Okay. Write the third one. So let me see if I can give you some questions regarding this. Let me see. We'll write the third one, then we will do some more problems here. Right, next. Metals placed above hydrogen can reduce H2 gas on reaction with dilute acid solution. Okay, so it will also predict for you what it will also predict for you the reactions. For example, if I say what will the reaction with Mg plus HCl? Okay, Mg plus HCl, that means tell me Mg comes before hydrogen, yes or no? Please tell me in the electrochemical series. Mg comes before HCl, before hydrogen. Mg comes before hydrogen, right? So what is going to happen? It will show reaction. What is the reaction that it will be showing? So Mg will react with, it will form Mg Cl2 plus it will what? It will reduce to H2. It can reduce H2 gas on reaction with dilute. Don't write, wait a second. Don't write reduce, write release here. Release will be a better word. Release H2 gas on the reaction with dilute acid solution. Okay, but if I have, let us say, copper plus HCl, then what you will say? No reaction. Okay, copper plus HCl will give you no reaction. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Right, next. Now, this is the second part of the chapter, which deals with conductance of electrolytic solutions and how do we measure this type of conductance. Okay, so the main heading will be what? Conductance. Please write. Conductance. Okay, so those of you remember, when did you first learn about conductance? You learned about conductance in your class 8 or 7, 6 standard, where you learned about the metals. Yes or no?
Yes.
So we all know till now what we all know about what the metallic conductor. Is that right? Yes or no? Please tell me. We all know about the metallic conductor. But there is also one more type of conductor that we'll be studying in this class. That will be what? That will be your electrolytic or electrolytic conductor. Okay. Actually, for this we will write there are two types of conductors. There are two types of conductors. One is metallic conductor. The second one is electrolytic conductor. Metallic conductor and electrolytic conductor. Okay. Now write make a box like this. Okay. And in this we will be writing about both of these conductors. Sarah, how much of this chapter is done in school now?
It's almost over.
Please write metallic conduction and then write electrolytic conduction. Now, in metallic conduction, what is the charge that moves? Charge carrier is what? Charge carrier, tell me. What is the thing that moves in the wire that conducts the electricity?
Current.
Current. There is some particle na. Current के opposite direction में क्या move करता है? What moves in the opposite? Electron, right? So the charge carrier is what? Charge carrier is electrons. Okay, and here the charge carrier will be the charge carrier. These are ions. Okay, these are ions. And the second point. Now, in metallic conductance, is there any chemical change? When we move some electricity, does the copper wire change to something else? No, the copper wire is still same. So we will write there is no change in chemical properties. No change in chemical properties no change in chemical properties of what? Of the conductor, of conductor. What about electrolytic conductors? So in this case, what can happen? There can be decomposition of some materials. Okay, decomposition of the electrolyte. So electrolyte will change into its solid state. Okay, so please write involves decomposition of electrolytes. That means what is happening? There is some chemical reaction that is taking place. Now, in the third case, if I move current across a copper wire, then its mass and all, it will not change, right? So there is no transfer of mass happening whenever we are running electricity through the wires. So we'll write that there is no transfer of mass. Doesn't involve transfer of mass. Let us write doesn't involve transfer of mass. Now, in this case, obviously, when the ions are getting decomposed into its compound form, then what will happen? There will be some transfer of mass. Okay, it involves transfer of mass. Now, the last point is very important. Last point says that, so what happens to the conductance when the temperature increases? For metallic conductor, tell me. भूल गए, सब भूल गए. अभी आप लोगों ने इसमें भी इलेक्ट्रिसिटी है ना चैप्टर आप लोग का 12th क्लास में. You have this chapter ना, करंट एंड इलेक्ट्रिसिटी. अहमद, फातिमा, सारा.
Yes, sir.
उसमें तो होगा कंडक्टेंस. Please write. Metallic conductance decreases on increase in temperature. But the thing about ions in the electrolytes is electrolytic conductance increases on increase in temperature. Write this 4 points. Sarah, do you use any book as a guide or reference?
I use the one which Akash provides.
Those modules, right? Okay. What about Fatima? Do you have any book? Yes,
Sir,
Fatima.
what did you ask?
Do you have any book that you use for reference or as a guide?
No.
No. Ahmed, what about you? No. Done all of you, yes or no? Please tell me. Is everyone done?
Yes, sir.
Okay. Right, next. So this is just a reminder that classification of electrolytes. Electrolytes are of two types, strong and weak electrolytes. Okay, so please write classification of electrolytes. Electrolytes are of two types. Number one, there are some strong electrolytes. And number two, weak electrolytes. I hope you guys are not hearing this for the first time. In 11th standard, you must have heard these words, strong electrolytes and weak electrolytes. Now write for strong electrolytes. So what are strong electrolytes? They completely dissociate. They completely dissociate into its ions in solutions. So if you will add them into water, then what will happen? They will completely dissociate. For example, NaCl. If you add this into water, then what is going to happen? They will form Na plus aqueous plus Cl negative aqueous. Okay, so there will be no any, you will not see any salt there. Hai na? So salt, as you see in its solid form, that salt will be not present. That means all of it has getting what? All of it has dissociated into ions and they have been dissolved. Similarly, let me write some other examples. NaCl is there, KCl, HCl, NaOH. There are also something such as MgCl2. Then you have NH4, NO3. Okay, so let me write what is NH4NO3. So it will transform into NH4 positive plus NO3 negative. So these will be the ions for NH4NO3. Okay, so for others, I hope you will know how they will dissociate. So these are strong electrolytes. Next is weak electrolytes. Weak electrolytes, what will happen? So these, they will not dissociate completely into ions. Okay, just the opposite, they don't dissociate completely into its ions in solution. Into its ions in solution. Okay. So what will happen? So if you have, for example, CH3, COOH, so they will have CH3, COO negative plus H positive, and this H positive will again, it will again get associated with CH3CO, and it will form what? COH, and that is why it is what it is. These are reversible in nature. What? These are reversible in nature. So for, let us say you have taken 100 CH3COH. Okay, and then when you see the solution here at time 0, it is nothing. Then out of 100, 50 will dissociate. 50 will be CH3CO negative form, and 50 H plus will be formed. Okay, so how much is getting formed? Alright, you must have learned this in solution line. क्या बता रहे हैं आप लोग को? याद है कि नहीं याद है आप लोग को? Yes or no? Fatima, Sara, solution से याद है ये? Fatima, you were there. Van 't Hoff factor or no? Fatima,
I was there, I think.
है ना? Sara, what about you? आपको तो याद ही होगा, इक्विलिब्रियम भी पढ़ा है 11th क्लास में आपने.
Yes, sir.
Yes, ठीक है. अहमद, solutions you have learned, complete किया आपने solution? Van 't Hoff factor वगैरह?
Yes, sir.
Yes, तो ये सुना सुना लग रहा है ना?
Yes, sir. But I didn't study that chapter much because it got cancelled.
Because
So solutions got cancelled, sir.
solution got cancelled.
Uh,
Solid state got cancelled, ना? हाँ बाबा. Solid state got cancelled, not solutions. Okay, अहमद?
okay, sir.
हाँ, ये information सही रखिए आप कि क्या cancel हुआ है. I hope I am right. Sara, Fatima?
Yes, sir.
Okay, fine. हमको लगा कुछ नया फिर आ गया क्या? So, out of 100, अच्छा फिर अहमद only you will answer. Okay, keep your mic on and tell me, out of 100, how many got associated? Tell me. Out of 100?
So 50.
50. So this is a ratio, right? And this ratio is known as alpha. It is represented by alpha. It is known as degree of dissociation. Okay. So different type of weak electrolyte, they have different degrees of dissociation. Fine. याद रहेगा all of you? Yes, Ahmed, tell me.
Yes, sir.
You remember alpha? Okay. Fine.
Yes.
Achha, if I talk about the alpha of NaCl, for example, alpha of strong electrolyte will be what? Out of 100, how many? So they are out of 100, how many are getting dissociated? They say completely dissociate. That means out of 100, 100 will get dissociated, and the alpha for strong electrolyte will be equal to 1. Okay, so I will write these points in a note also, but please write with me. They don't dissociate completely into its ions in solution. And the examples you can write, such as what I have done first: CH3COOH, H2CO3, H3BO3, and ZnCl2. Other group D elements, they make some weak electrolytes. HgCl2 is there. Then what else can be there? Weak acid is HCN. So they will not dissociate. Okay, so they are not going to dissociate. Okay, similar to NH4NO3, we have one more, which is NH4OH. So it dissociate into NH4 positive and OH negative, but not completely. So all of these are what? These are weak electrolytes. These are weak electrolytes. Now please write note. Note. Degree of dissociation. Degree of dissociation that we represent by alpha. What is degree of dissociation? the fraction of total number of molecules of electrolyte which ionize in the solution. Okay, it is represented by alpha. Next point, alpha for strong electrolytes is equal to 1. You can write almost equal to 1. Okay, we have written almost just to be scientifically more accurate. Okay, because nothing can get completely dissociated. Okay, in theory it cannot get completely dissociated. Lekin the fraction of NaCl which will be remaining in the water, it will be immeasurable. That means you cannot measure it. That means for the practical sense it is equal to 1 only. Practical sense mein kya, it will be always equal to 1 for strong electrolytes. Alpha for weak electrolytes, alpha for weak electrolytes, it will be what? It will be always less than 1. Write this down. And then you will see what are the factors that affect the electrical conductivity of electrolytic solutions or electrolytes. Let me know if you are done, guys. Please let me know if you are done. Ahmed, Sarah.
Done.
Sorry, factors affecting electrical conductivity of electrolytic solution. Of electrolytic solution. Okay. There are a number of factors that affect. Please write. Okay, let me explain it to you first. Okay, so we have some here ions. Okay, we have ions. And ions are what? These are charged species. Positive ions and negative sign will be there. And if there will be current, what will happen? In the influence of current, in the presence of electrical field, these ions will move and they will also move the electrical current. Okay, it will also move the current. So now you tell me the conductivity will be higher or lower. How it will depend on the number of ions, tell me. Will conductivity increase if I increase the number of ions or decrease if I increase the number of ions? Tell me. Will there be more current flowing if there will be more ions? Yes or no? What will happen to the conductance?
It will increase.
It will increase, right? All of you, Sarah, Ahmed, Faiz, Fatima.
Yes.
Yes? Okay. This is completely logical, right? If I increase the number of ions, ions are the one which are charge carriers. And if I increase the number of charge carriers, that means the conductance will increase. That means the conductance will increase. Okay, that means what if I ask you which will have more conductance? The strong electrolytes or the weak electrolytes? Tell me, which gives more ions, strong or weak? Which one gives more ions, strong one or weak one? Yes, Fatima, tell me, which one will give more ions, strong one or the weak one?
Strong.
Strong one, right? Okay. Ahmed, Sarah, agree with the answer?
Yes, sir.
ठीक है. So that means if I add strong electrolyte, they will be having more conductance. Okay, they will be having more conductance. Okay. After that, let us suppose we have the solvent here. We have ions in which are present inside a solvent, and you know viscosity. Tell me, do you know what is viscosity? And if I ask you which is more viscous, water or honey, which is more viscous? Water or honey? Water or honey? Which is more viscous? You don't, ये ऐसे बस हम नाम लेके आप नाम ही एकदम सारा बताइए. Which is more viscous, Sarah? Water or honey?
Honey, maybe.
Honey, right? Okay. Ahmed, Fatima. Yes, Ahmed and Fatima, tell me which is more viscous, honey or water?
Honey.
Honey. Okay. So honey. You understand now what is viscosity and viscous liquids? Yes or no? Tell me. अरे
Yes.
हाँ या ना जल्दी जल्दी बोलिए प्लीज.
Yes.
No, हाँ या ना सवाल पूछ रहे हैं आप लोगों से इतना टाइम लगा रहे हैं. Okay. So what do you think the ions will move easily in water or in honey? This is less viscous and this is more viscous. Water, in water they can move more easily, है ना? So that means the next thing is solvent that will also affect the conductance. That will also affect the conductance. Okay. Now, what do you think about the concentration? What do you think about the concentration? Tell me. If I increase the concentration, then the conductance will increase or decrease?
Increase.
Increase.
Okay. All of you?
Yes, sir.
See. This is something that you have to understand about concentration. When the concentration increases, उल्टा कर दिया हमने. I should have made white ये and then water like this. If I keep adding NaCl, then water will dissolve some NaCl. Then again it will dissolve some NaCl. Again it will dissolve some NaCl, right? But there will be some point where what will be happening? NaCl will be saturated and you will see some NaCl which is undissolved. Yes or no? Please tell me. If I
Yes.
keep adding, right? If I keep adding. Now, can you see if I increase on increasing the concentration, what is happening? The degree of dissociation alpha is decreasing. Yes or no? Earlier, when we were having dilute solutions in which the NaCl I was adding a little bit of NaCl. At that time, what was happening? At that time, we had complete dissociation and all of the NaCl molecule it dissociated. But as I start to increase the concentration of NaCl, what happened? Some NaCl also started getting to associate. That means the degree of dissociation has now decreased. Now, if the degree of dissociation has decreased, then obviously what will happen to the conductance? The conductance will decrease. Do you understand this point? Yes or no? Tell me. Fatima, Ahmed, and Sarah.
Yes.
Yes.
Okay. So these are the four things. These are the three things, and then the last thing. When we add NaCl, ना, तो इसका तो हमको like I should have always this as a template picture. Wait a second. NaCl solvation. Solvation. Okay. So see, if I ask you which will move faster, a big ion or a small ion? Which will move faster, big ion or small ion?
Small ion.
Small ion will move faster. So this is something that we have, and this is very correct also. The small ion will move faster. But as soon as you will add this ion, as soon as this ion will be formed inside water, what will happen? They will get solvated. Can you see Na plus and Cl negative? They are surrounded by what? They are surrounded by water. Can you see this? Yes or no?
Yes, sir.
And this Na plus, this is oxygen. Okay. Yeah. This is oxygen, and these two are hydrogens. Okay, all of you. This is water, oxygen, and hydrogens. Now, we were thinking what Na plus is only this much big. And we were commenting about Na plus on the basis of this size. But actually, inside the solution, it is this much big. Why? Because if the Na plus is going to move, then means it has also got to move all the water molecule that is surrounding, or which is solvating the Na plus ion. Is that correct? Yes or no? Please tell me. So this was the expected size, right? And it is correct. But as soon as we will add NaCl in water, what will happen? The ion will be having this much big size, because if Na plus is moving, then all the water molecules will be moving together. Ahmed and Fatima, you understand this point? Yes or no? Tell me.
Yes, sir.
Okay.
Yes,
So
sir.
as you can see, now you tell me, where is the positive charge located? It is located where in the atom? Inside the nucleus, outside the nucleus?
Inside.
The positive charge inside. No. So whenever you will have positive charge like this, it will be always where it will be inside the nucleus. Okay. Now you tell me, if I have a positive charge here like this, and it is a very small ion. So this is the ion size, and I have a positive charge, and the ion size is this much big. Then what do you think, which will be more able to attract the water molecules, the small one or the larger one? Which will attract more? Larger one?
Larger one.
Larger one. Okay. कैसे देखिए? If water is getting to the smaller one, oxygen will be here, right? And if it is getting for the larger one, the oxygen will be here. Okay. Now let me make it a bit. Acha. You see here that the distance from nucleus and oxygen is this much larger here. If I talk about the same distance here, then I can say that there can be some more water molecules which can be attracted by the nucleus in the same distance. Yes or no? Tell me. Aisha? Sorry. Fatima and Sarah?
Yes, sir.
Enough. Right? Since the positive charge is very near to the boundary of atom, more water molecules will be attracted on the smaller one, right? And here the positive charge is very far away from the boundary of atom. That is why less number of water molecules will be attracted. So smaller ions have larger solvated ion. Okay, you will remember this. Okay, so we have discussed all of these points, and what we will do now, we will now write them. Okay, so you'll please start writing with me. So you have written this topic, right? Factors affecting electrical conductivity of electrolytic solutions. In that, you write the first factor, You'll write nature of electrolyte. In this, what we will write? Strong electrolytes have higher conductance than weak electrolytes as the strong electrolytes dissociate completely and give more ions. Right, the second point, nature of solvent and its viscosity. Nature of solvent and its viscosity. Okay, so in this you will write electrolytes ionizes easily in polar solvents and hence what should I write? And hence they show greater conductance in polar solvents. Okay, the same thing you will write greater viscosity leads to lower conductance. We can write lower conductance. Okay, at the third point, size of ions produced by the ion produced and solvation. Okay, and solvation. Okay, so in this you will write when the ions are effectively solvated, what will happen? Their effective size will increase and hence conductance will decrease. Fourth point, concentration. In concentration, you will write higher the concentration of solution, lower is its conductance. Lower is its conductance. Okay, so for this you will write 2 points, one for the weak electrolytes and the one for strong electrolytes. So please write, in weak electrolyte, the ionization decreases with increase in concentration. And hence what will happen? The conductance is lower and therefore lowers the conductance. Next point you will write about the strong electrolytes. Right? In strong electrolytes, the interionic interactions increases on increase in concentration. Interionic interactions, that means if you have more Na plus and more Cl negative, that means Na plus and Cl negative will be very near to each other, right? And if we have very less number of Na plus Cl negative, that means they will be very far away and they will not, the chances of them colliding with each other and forming NaCl will be very low. But if I increase the concentration, chances of them colliding increases, and that is why the interionic interactions also increases, which leads to what? Lower end dissociation. So we'll write increases on increase in the concentration and hence and therefore lowers the conductance. Okay, now write the fifth point that we have written already while we were writing the difference of electrolytic conductance and metallic conductance: temperature. So when we are going to increase the temperature, what is going to happen? The ions will move faster, and when the ion will move faster, what will happen? The conductance will increase, right? With increase in temperature, the conductivity of an electrolyte increases due to what? Due to decrease in interaction between ions. Same. I hope you guys were writing with me, है ना? ऐसे बैठे हुए तो नहीं थे ना आप लोग? Yes, Fatima, Sara.
Yes, sir.
Yes, okay. So complete this. Let me know when you are done.
Done, sir.
Sara and Fatima, what about you guys?
Yes, sir.
Done, sir.
Okay. Acha. So now what I'm going to do, now we will talk about we have talked about how the conductance is affected by different factors. Now we will talk about the main, what we say as the meat of the topic, the main topic, that is electrolytic conductance. But before, I mean, not before that, in that only what we will do, we'll revise the Ohm's law, resistance, resistivity, specific resistance, conductance, conductivity, all of these things with their units. Okay. And then after that, All of these things are there in physics also. Yes or no? You remember these words, right? Ahmed, Fatima, Sarah.
Yes, sir.
Yeah. Now all of these are physics word. Then for the electrolytic conductance, we will introduce at last the molar conductivity or the molar conductance. Okay, molar conductivity or molar conductance. Okay. So please write now the topic electrolytic conduction. So what is electrolytic conductance, conduction, or what is conductance or conductivity? Please write. The power of electrolytes to conduct electric current is termed as conductance or conductivity. Conductance or conductivity. Okay. See, so when you have something like this, so here we have solution. So these are two, you can assume them to be electrodes connected through wire, some kind of battery. And here we have some water and there will be some ions present. Okay. So now when the electricity will flow, it has to also flow through the ions, right? So whatever is flowing through the ions, the current that is flowing through the ions, that is through the ions. It is due to the presence of charged ion, positive and negative ion. And this is how the conductance happens. Okay. This is how the conductance happens. Show you some more pics if I can show you guys. Hmm. Okay, see this picture. Okay, see here. I will give you a bit of what is electrolysis and different things and how decomposition happens. See, the electrons are coming like this. How will the current flow? Current flow in this direction, right? From the positive end, like this, like this, like this, and like this. And in the opposite direction, the electrons will be moving. In the opposite direction, the electrons will be moving. So we will say that from the negative end, this is negative end, this is positive end. So electrons are coming here. If the electrons are here, that means all of this will be what? Negatively charged? Yes or no? Please tell me. These are all negatively charged, correct?
Yes, sir.
Okay, if this is negatively charged, that means the Na plus ion will be attracted and it will be going this side and it will be sticking on to the electrode, correct? Yes or no? है ना? Na plus will be going here and what it will be finding? Na plus will find electron and it will decompose into Na solid. Is that right? Yes or no? Please tell me. Correct? Hai?
Yes, sir.
Okay.
Yes.
Similarly, Cl negative will go in the opposite direction, and what it will do? What it will do? Cl negative will go in this particular electrode, and it will give you half Cl2. There will be gas here, it will be popping, plus an electron. Okay, so this is how the conductance happen. Now please remember, see, this can go, and this I'm also Cl negative can also go, and you should also remember that there is water also. So water also has some kind of dipole. Okay, so water can also move and it can also get decomposed or something. So we'll see what are the different products that is formed in different types of electrolysis later on. But now you must have got an idea how things can get decomposed and how the electricity it moves in the electrolytic solution. Is that right? Yes or no? Please tell me. Can I move on to the next topic?
Yes,
Yes
sir.
or no, guys? Okay. Chaliye. Please write Ohm's law.
So are we supposed to draw that?
No, you don't. This one?
No, the other one.
This one? No, you don't need to draw it. Okay.
Okay.
We'll be looking at NaCl aqueous, NaCl molten, all of these states, then you will draw Ohm's law. What is Ohm's law? Tell me. What does it say? It says that whatever the current is flowing, current is denoted by I, whatever the current is flowing in the conductor will be directly proportional to the potential. That means it will be directly proportional to the potential. So I will also write current, because आप बाद में भूल जाइएगा I क्या है, is directly proportional to the potential difference of potential. And after that we get a constant. What is that constant?
Rho.
Not rho. Rho. What is that? Tell me.
Resistance.
1 upon resistance. Actually, it is conductance. Okay. Now I will try to teach you this. Okay. If the current is flowing, so more current will flow if the conductance is higher. Yes or no? Correct. More current will flow
Yes.
if the conductance is higher. Okay. More current will flow if the resistance is lower, right? Yes or no?
Yes.
If the so that is why the I is equal to 1 upon R into the potential difference, and it gives you what? Potential, it is equal to IR. Okay, so this is Ohm's law. Now let us see what is resistance, resistivity, conductance, conductivity. Fine. Can I move on? Yes or no? All of you have written.
Yes, sir.
All right, resistance. What you will write? You'll write resistance. Please write. So resistance definition लिखाने की जरूरत नहीं है ना, I hope. What does it measure? It measures the magnitude of obstruction in the flow of current, है ना? How much it is getting barrier. आपको ये याद होना चाहिए बस that resistance is equal to what? It is equal. Sorry, I should say that it is directly proportional to the length of conductor. Yes or no? And we also know that resistance is what? It is inversely proportional to the area, cross-sectional area. Clear? Yes or no? Please tell me.
Yes.
And that means R is what? It is directly proportional to L upon A. And then for this we write a constant rho, L upon A. Got it? Yes or no? Please tell me.
Yes, sir.
Okay. What is this rho?
Constant.
What constant? What it is called?
Resistivity.
Very good. Resistivity. एक और नाम क्या है इसका? Specific resistance. Specific resistance. Is this clear? Yes or no? Please tell me.
Yes, sir.
Okay. Now you will write the topic. Resistivity or specific resistivity. A specific resistance, sorry. Resistivity or specific resistance. देखिए, resistivity or specific resistance is the constant, and whenever you have to define a constant, there is only one way of defining each and every constant. अभी जो हम अभी बताएंगे, प्लीज इसको याद रखिएगा. I have told this in, I have not told this thing in 11th class, but still you will see the hint here. Okay. What is the formula? Tell me. R is equal to
Rho L
R is
by
equal,
A.
rho L upon A. Rho L upon A. Whenever you have to define a particular constant, you will always have an equation, and you will take a case in which L is equal to 1 and A is also equal to 1. So whatever variable you are having here, whatever variable is there, you will assume a case in which those variables, they have a magnitude of unity or magnitude of 1. ठीक है? For example, देखिए आप लोग अगर याद करिए, we also defined P is equal to KH into chi v. What is this? This is Henry's law. What is KH? KH is the vapor pressure when mole fraction is equal to 1. याद आया? It is the vapor pressure when the concentration of a solution is 1. When the mole fraction, when the concentration of the solution is what? Mole fraction is equal to 1. Do you remember this? Yes or no? Please tell me.
Yes.
है ना? So this is how we always define. This is how we always define what? The constant. So you'll write what is resistivity or specific resistance. If L is equal to 1 centimeter, A is equal to 1 centimeter cube. That means we have taken a particular conductor whose length is 1 centimeter and its cross-sectional area is also what? It is 1 centimeter cube. Okay, like this. And then we have measured sets. So what will be happening? R will be equal to what? Rho into 1 upon 1. So R is equal to rho when L is equal to 1 centimeter and A is equal to 1 centimeter, sorry, square, not cube, 1 centimeter square. Please write resistivity is defined as the resistance of a conductor whose it is conductor of 1 centimeter length and 1 centimeter square cross-sectional area. Cross-sectional area. Clear? Yes or no? Please tell me. Is this clear? Yes or no? Okay. Let me write units. So if I look at units, the unit for R, what R is equal to ohm. Therefore, the unit of R is equal to rho L upon A, which will imply rho is equal to what? Rho will be equal to A into R upon L. So A will have the unit of centimeter square into ohm upon centimeter. So this will be what? For rho, the unit will be ओम सेंटीमीटर। अरे यहाँ पे ऐसे लिखेंगे ना तो बाई लगेगा, इसको और लिख देते हैं, और इट विल बी ऑन ओम सेंटीमीटर लाइक दिस. But the SI unit will be in meters. Okay, so SI में हमेशा याद रखिए, it will be ohm meter. But in chemistry we generally use centimeter because centimeter cube it is equal to 1 ml, and if you have 1000 centimeter cube it will be 1 liter. Done? Yes or no, please tell me.
Yes, sir.
Okay. Now what will be the conductance? Conductance is the measure of what ease with which the current flows. So resistance ka just ulta, resistance ka just ulta. Conductance is shown by very awkward thing G. Does anyone know why it is expressed as G? Conductance. Okay, I got it. There was a scientist Luigi Galvani. जिसके नाम पे galvanic cell भी है, right? So I think so what I have saw is G is because of this Galvani, Luigi Galvani. He invented conductance. That is why he discovered conductance rather. That is why we have denoted conductance with G. Okay. Now what will G be equal to? G will be equal to 1 upon R. G will be equal to 1 upon R. And the units, it will be equal to what? 1 upon, what is the unit of R? It is ohm. So it will be what? It will be ohm inverse or ohm inverse or mho. नाम ही उल्टा कर दिया, right? MHO, mho. Also right? According to SI units, it is Siemens. SIEMENS. Denoted by S. Conversion factor कुछ याद रखने के लिए आपको जरूरत नहीं है. 1 Siemens it is equal to 1 mho. Got this? Yes or no, please tell me. आगे बढ़े. आगे बढ़े. Conductivity. भाग्य क्या आप लोग?
Yes.
हेलो. ओके. कंडक्टिविटी टेस्ट भी देना है आप लोग को. आई होप यू गाइस रिमेंबर आज की क्लास 2 घंटे की है. यस और नो? चलिए ठीक है. कंडक्टिविटी लिखिए क्या है. कंडक्टिविटी इज शोन बाय, ये कैसे लिखते इसको पता नहीं, कापा बोलते हैं इसको, तो ये दैट इज आई नो, बट हाउ डू यू राइट इट प्रॉपर्ली? आई नेवर हैव अंडरस्टूड. समथिंग लाइक दिस, इट इज नोन एज कापा. Okay, conductivity is kappa, and kappa will be equal to 1 by rho. Okay, what will be its definition? It is the conductance, it is the conductance of a conductor with 1 centimeter length and 1 centimeter square cross sectional area. Cross sectional area. If I define this in terms of solution, I will say that it is the conductance of a solution ना, क्योंकि solution ही हमारा क्या है, कंडक्टर है with 1 centimeter length and 1 centimeter square cross sectional area. अगर हम इसकी बात करें, then we can also write this as what? That is, it is the G of, that means conductance of a solution with volume. Length is 1 centimeter, area is 1 centimeter square. If you multiply both of these things, you will get the volume, which will be equal to 1 centimeter cube. With volume 1 centimeter cube. Shall you please write this down? Done? What happened? Done.
Done, sir.
Done, sir.
Right, next. Units. So kappa will be equal to 1 upon rho. And rho has the units of what? Rho has the units of ohm centimeter. So kappa will have ohm inverse, centimeter inverse, or ohm inverse is equal to what? More centimeter, or you can also write something like this. Or you can also write it as ohm inverse, it is equal to what? 1 Siemens.
Sir, it should be more centimeter inverse.
More centimeter inverse, my bad. Okay, or Siemens per centimeter. Done? आगे बढ़े?
Yes.
Okay, chaliye. That is it, by the way. So just take 2 minutes, okay? And after 2 minutes, I will start the test. 2 minutes, it can take a bit longer also.
How many questions are there?
I have to not prepared only. How many questions you want, Fatima?
2 questions.
2 questions. Only 2?
Sir, I didn't prepare because when you told that time I went and looked on the WhatsApp.
हाँ, तो हमने तो पहले बता दिया था, आपने मैसेज किया था, हमने उसी टाइम बता दिया था.
But I didn't see the message, no.
हाँ, तो वो तो आपकी गलती ना. लाइक इसमें हम क्या कर सकते हैं, इसमें बताइए आप. Should see the message. गिव्स फ्री एनर्जी तक है, राइट? यस और नो? गिव्स फ्री एनर्जी का तो सवाल सब जो होता है, दोज आर इजी क्वेश्चंस, राइट? यस और नो? हाँ, I have also told you guys that those are easy questions. Gives free energy वाले सवाल भी तो मिल जाए. 2 MCQs and 2 questions.
Okay.
देखिए 2 क्वेश्चन देने में ना मतलब it is not even good for you guys also. You know why? Because अगर एक भी आपको नहीं आता है, ठीक है, मान लीजिए आपको एक भी सवाल नहीं आता, फिर तो गया ना, वो पूरा सवाल चला जाएगा. So if you have more number of questions, that is better only. So question number 1. So question number 2. Can you guys see the questions? Yes or no, tell me.
Yes, sir.
Okay.
Yes, sir.
Okay. So you know the drill. 30 minutes, 10 marks. SHE, standard hydrogen electrode. Okay. So when you make the PDF, please write the file name of the PDF as your name. Okay. And uske baad mein agar aap, if that file is already made, then you can just add the date. File name, write your name plus date, है ना? अगर आपको दिक्कत होगी तो. Plus 6 July as the file name of PDF. Okay.
So should you write the questions also or just the answer?
No, just the answer, just the answers. For example, we have Ahmed, na? So when Ahmed, when you will write the file name of PDF, you'll write it something like this: AHMED 6 July, and it will be like this. ठीक है, Ahmed?
Yes,
Same
sir.
for Fatima Sara. Understood, na? Fatima Sara Ahmed, everything clear है?
Yes, sir.
Okay, fine. चलिए.
Sir, the first E naught cell in the third question is of chromium or cadmium. Okay, nothing. I didn't ask anything.
What, Fatima?
No, I didn't ask anything.
Okay, fine. See, the E naught cell is given. Okay, so for the whole thing, you don't even have to calculate E naught cell. I gave the E naught cell. Okay.
Sir, I'll send the file on WhatsApp.
Send the file on WhatsApp.
Sir, should I send it to you or the Learnivio number?
Send it to me. Send it to me. Sarah, I have received yours. Okay, if you want, you can leave the class. Thank you. Bye-bye. Take care.
Thank you so much.
Sir, I've sent, sir.
Hi, Ahmed. I have received yours. Thank you. If you want, you can leave the class. Okay. Bye. Take care.
Thank you, sir.
So I also just sent it.
Yes, Fatma, I have received yours also. Thank you. Thank you very much.
Yes, sir.
Bye.
Bye bye.